Okay, so this set of notes is going to cover atmosphere. It's going to talk about the different gases that's in the atmosphere, and it'll also talk about the atmospheric layers and what happens in each layer. So the definition of atmosphere is just an envelope of gases that surround Earth. So Earth is the planet we live on. There are several gases that are surrounding Earth, and this is considered our atmosphere. Now, some of the gases that are part of our atmosphere are nitrogen, oxygen, and carbon dioxide. So looking at this pie chart, it kind of shows you a percentage of what our atmosphere is composed of. The main thing that our atmosphere is composed of is nitrogen at 78%. A lot of people think that oxygen is the main gas in our atmosphere, and that is not true. Okay, nitrogen is the most abundant gas. Next is oxygen at 21%, and then that last 1% are other gases. So we just mentioned how nitrogen was the most abundant gas in the atmosphere, coming in at 78%. And the second most abundant gas in the atmosphere is oxygen at 21%. Now this picture kind of shows you something cool. If you look, I'm going to highlight all the nitrogens. So it kind of shows you how many different nitrogens are in the air compared to the amount of oxygens. So there's much more nitrogens than oxygens in this air, and that just goes to show you the higher percentage of our atmosphere is nitrogen, and the second highest is oxygen. Carbon dioxide and water vapor make up that last 1% of gases. A lot of people don't think water vapor is a gas, but it is. Carbon dioxide, I'm sure you've all heard of before. It is given off whenever fossil fuels are burned. So whenever you're burning coal or oil, carbon dioxide is what's produced from that burning. And that falls into that last 1% of gases of our atmosphere. And water vapor is the reason why our air is never completely dry. So if you look at this picture here of the globe, this shows you the different areas where water vapor is the highest and where water vapor is the lowest. So if you notice, in all the areas of red and orange, these are our highest areas of water vapor with the most amount of water vapor. So in the center here is the equator. So most of our warm areas are going to be our areas that have the most water vapor. Looking at the poles here, those are all the blues and the greens and stuff with the least amount of water vapor, which goes to show you that cold air does not have as much water vapor as warm air does. So warm air can definitely hold more water vapor than cold air. Those 1% other gases that I'm talking about have a name, and the name we call them are trace gases because there's just a trace of them in the atmosphere. The pie charts below kind of show you some examples like argon, methane, helium, neon, carbon dioxide. All of those other gases combined together make that 1% of trace gases. In our air, most of the time we think of air as just being something fluid, but there's actually particles in the air that we can't really see. So these particles are found in the air as liquid and solid pieces that kind of float around. Because of this, there is no such thing as pure air. Okay, the air we breathe in are always going to have particles in it, except for if it's in some controlled area in laboratories. So a way to remember the different gases is this acronym right here. Never offend crazy women. Okay, my picture here shows some weird old lady chasing after a guy with a broom because she's crazy and he's obviously done something to offend her. So if you remember never offend crazy women, then you're going to remember the most abundant gas to the least abundant gas for the composition of the atmosphere. N standing for nitrogen, O oxygen, C carbon dioxide, and W water vapor. Never offend crazy women. Don't forget it. So why do we have to learn about the atmosphere? Why is it important? A couple of reasons. It makes conditions on Earth suitable for living things. What I mean by that is the atmosphere is the main reason why we can breathe in oxygen or why we're not burnt to a crisp. Okay, so there's different layers in the atmosphere that provide these things for us to keep us living. The second thing is obviously it contains oxygen, which not only humans need, but other things in the environment need to survive. The third thing is it traps energy from the sun. So whenever energy comes down, it kind of keeps that warm energy in our atmosphere for a little while and down at the layer that we live in. And since it keeps it warm, our water obviously doesn't freeze into a solid 24/7. So our water is kept in the form of a liquid because of the warmer temperatures, and we need liquid water to survive. The fourth thing is that the atmosphere also helps protect us from harmful radiation. So there's a kind of a small layer in the atmosphere whose specific role is to protect us from harmful UV rays. So I keep talking about these layers of the atmosphere, and they're actually broken down into 5 layers. And you need to know that we consider each layer and the different changes based on their temperature. Okay, so we can figure out the layers of the atmosphere because of the temperature changes that happen as you go through each layer. So the first layer is the troposphere, then the stratosphere, mesosphere, thermosphere, and exosphere. Okay, troposphere is closer to where we live. Stratosphere is the next layer. Mesosphere, thermosphere, exosphere, being the furthest away from Earth. Okay, so a way to remember the layers based on how close it is to us and then going out into space. The troposphere, stratosphere, mesosphere, thermosphere, exosphere can stand for the smart man tricks everybody. So T for troposphere, the. S for stratosphere could stand for smart. M for mesosphere, man. T for thermosphere, tricks. And E for exosphere, everybody. Smart man tricks everybody. Troposphere, stratosphere, mesosphere, thermosphere, exosphere. Remember it. So let's talk about what happens in each of these layers. The troposphere is the first layer, which is the layer that we live in. The prefix tropo stands for turning or changing. All right, so the troposphere is constantly changing. It's the layer that we live in. It's the layer that weather occurs in. Up at the very, very top of the troposphere is where the planes fly. All right, and as you go up into the troposphere, the air temperature will decrease. So it goes from warm at the surface up to cooler temperatures. So I'm going to write cool here. Okay, so the temperature decreases as you go up higher in the troposphere. The troposphere has the highest amount of air pressure versus any of the other layers because there's so many air molecules down in our layer where we live. The next layer is the stratosphere, prefix strato, which means spread out. The stratosphere is a cool layer because it kind of has a sublayer in it, and that sublayer is called the ozone layer. The ozone layer is the layer I was talking about earlier that protects us from harmful UV rays. So if we did not have the ozone layer, the harmful UV rays coming down from the sun could cause skin cancer in all of us, could cause harmful radiation. So because we have the ozone layer, it protects us from these things. With the stratosphere, it is the exact opposite of the troposphere. So remember how in the troposphere we said that it went from hot at the surface to cold? Well, the stratosphere is the opposite. Okay? It's cold and then it gets hot. One of the main reasons that it gets warmer as you climb in it is because it has the ozone layer, which is absorbing those heat rays. The next layer is the mesosphere, and the prefix meso means middle, so this is kind of your middle layer of the atmosphere. The mesosphere protects us from meteors. The way I remember that is the ME in mesos and the ME in meteors. All right. So the mesosphere protects us from meteors. So when the meteors are coming in through space, it's billowing down through our atmosphere. It's going to blow us all to smithereens, except for it's not, because the mesosphere is a layer that breaks apart these meteors so that they don't come down and hit us. And it kind of, when it breaks apart, it gives off the look of shooting stars. So the mesosphere is going to be your coolest layer. We just talked about in the troposphere how it went from hot to cold. Stratosphere did the opposite, cold to hot. Now this one's going to go this way again, okay? So it's going to go from hotter temperatures to cold. So as you climb in the mesosphere, it gets very, very, very cold. The thermosphere is your hottest layer. Obviously, the prefix thermo is going to mean heat. So that's how you're going to remember that the thermosphere is the hot layer. The thermosphere has a sublayer inside of it called the ionosphere. And that's ionized by radiation. It pretty much means that the ions in this layer are going to bounce back waves, like radio waves, back to our surface. The thermosphere is going to increase in temperature as you get higher. So the higher up you go in the thermosphere, the hotter it is. So let's remind ourselves. Troposphere went from hot to cold. Stratosphere went to cold to hot. Mesosphere, hot to cold. Thermosphere, cold to hot. See how they're constantly changing and going back and forth? That's why the layers of the atmosphere are categorized based on their temperature changes, because each layer has a different temperature change as you go up. The exosphere, some people kind of consider part of the thermosphere, some people consider it its own little layer, but either way, exo means outer, so that's the outermost layer. It's the layer that's going to connect to space and fade off into space. In this layer, you're typically going to find satellites that are orbiting out around Earth. The last thing we need to talk about are the different separations between the layers. There are things called pauses. Between each layer is a boundary that separates them called a pause. What the pause called it from the troposphere to the stratosphere is the tropopause. From the stratosphere to the mesosphere, stratopause. From the mesosphere to the thermosphere, mesopause. So you can see the prefixes in each of the words that separates the next couple of layers as you go up. And this picture is a good picture because it also shows you what's happening in each layer. So remember how we said the airplanes fly right at the top of the troposphere, beginning of stratosphere. Here are meteors right here coming through the mesosphere. You have aurora borealis, which are the northern lights up there with your satellites and your space shuttles. Okay, and then here's a little weather balloon in the troposphere because we all know weather happens in the troposphere. Okay, so if you guys have any questions about this information, we'll talk about it in class on Monday.